All right. Good evening, y'all. I'm Jared. I'm here with my friend Johnny, and tonight we're going to be talking about some questions based on probability and statistics. With that being said, let's waste no time. Let's get right to it with our first question.
So, how would you describe a stem and leaf plot?
That is a good question. Well, it can be decided. Well, first of all, a stem and leaf plot is based on the concept of a leaf where you have the stem serving as its base, and then let me get my laser pointer here. And then you have the stem as its base, and then it spreads out to create leaves. So with that in mind, we're going to split this up into two parts, tens and ones. So if our tens value is 1, and we had numbers of 10, 13, and 15 in our data, we would put a 1 here to represent the tens, and then 0, 3, 5 to signify the ones. Likewise, if we had 2 for the tens value in numbers of 21, 24, we would put a 2 here in the tens, and a 1 and a 4 in the ones place. And you can kind of see how this would work out if we extended that out to the 50s range, where we have other numbers like 37, 39, 42, and 50. All right.
All right, so what if you wanted to reverse the order or the roles of the stem and leaf? How would that work?
Uh, I mean, it would be it's doable, but it can get confusing. Allow me to demonstrate here. Let's say our leaf is now, let's say we make our leaf here the one, if our leaf was the tens value and we had like 1 here, where would the 0, 3, and 5 go? Where would the ones values go?
So, if you reversed it, then you put the one on the right side,
Hmm.
put the 0, 3, and 5 on the left of it, on the left of the line.
Correct. That would be the way you would do it based on how that question is worded. But
Okay.
the problem with that is people read usually from left to right. Going
Hmm.
from right to left just isn't how a person typically reads. And on top of that, 0, 3, and 5 just does not make sense. And it just reads a little weird if you showed somebody that. And I think they would get confused. Whereas if we put the tens values on the right, they would understand that. Okay, the 1 signals the tens, and these leaves, in this case, would be the ones value because they all branch off from the stem of what is 10. Likewise, here with 20. If if 20, we understand that the stem at 20 leaves creates 2 leaves in 21 and 24. Another good question.
Um, what inference can you make about the usefulness of a stem and leaf plot beyond the classroom?
Ooh, well, that's a good one. It can be the best way to represent a stem and leaf plot beyond the classroom is to recognize its application in this usefulness. It's a simple way to explain data. Like you can easily tell someone, show them this and say, okay, you have your tens values here on the left, ones on the right, and based on that, here are the numbers I've gotten. And if we want to put that into a situation, well, think of it like this. If you had people attending a party, you could use those numbers, the stem and leaf plot, to show the ages of the people who are attending. Now, what makes a stem and leaf chart unique is that it works. See here, if we had a bar graph, it it doesn't make as much sense because you can't see the specific ages. You just see we have 3 people who are 10 to 19, 2 20 to 29, and only 1 in the 50s. Likewise, this also applies to a pie chart. As you can see, once again, it just explains the age range, but it doesn't tell you specific ages. And so that's kind of the main thing.
So it just helps you keep data over a range of
Mhm.
numbers?
Stem
Okay.
and leaf plots give you specific numbers, whereas a pie chart or a bar graph, it's demonstrated here, just shows you ranges, and that would not work for a case if
Okay.
you were to say need those numbers. I like this. Got anything else?
Uh, can you explain to me a box and whisker plot?
Sure. First of all, we're going to split this up. It's created based off of boxes and whiskers. First of all, a box represents the quartile ranges, ranging from the lower quartile to the upper quartile. So this quartile is separated by a median. And then from your median, you have the lower quartile and the upper quartile. Finally, this stem, oh, not stem, finally, the extending from the quartile to the outer ranges is our whiskers. These whiskers typically go out from the quartiles to their lowest and highest extremes and usually represent the lowest and highest values that can be found in our data. And that is not a continuing line, that is an endpoint. All right. Thank you for asking.
How would you use this box and whiskers? Like, can you visualize the results of a test?
Yes, as a matter of fact, the best way to do is first of all, get some data to start off with. Like, say here we have these test scores, and to start off, we would want to look for kind of try to see what the median is. So we want to organize these in order. So we start off with 3 and 7 because those are our lowest values. Then we see it's 27 is our next value. Then it is 39, followed by 43. Oh no, I made a mistake. 32 is our fourth value. So 39 is our fifth value. 43 is our sixth value. Oh wait, 5, 6. 45 is our seventh value. 47 is our eighth value. And 48 is our ninth value.
So
with that in mind, we know that
3, 7, and then for number 3 we have 27, and then we have 32, and 5, 39, and then come over here to 43 for 6, and then 7 is 45, and then 47 is 45. 47 is
45 is 7.
Yeah.
47 is 8.
8, and then 48 is 9.
9.
Okay. So we have 9.
And what that's representing is the order of the number, is the order in which the numerical order in which the data is lined up. And that's really important because we now know that 48 is our highest value. Actually, let's say 50. Let's say this line goes from 50, but we'll put 48 here. So our whisker, we know, will have its highest extreme at 48, and its lowest extreme will be over at 3. Now, the median is the data that's right in between the highest and the lowest point. In this case, that is the fifth number. What is the fifth number?
The fifth number is 39.
Correct. So 39 is our median. So as a result, we will signify that as our median. And then from there, once we have our median, we have it set. Now we look towards data numbers 1 through 4. That is 3, 7, 27, and 32. That range represents our lower quartile. Now, the median is going to be somewhere between numbers 2 and 3, and you'll find that for your lower quartile, and then you'll repeat that process here for your upper quartile. And eventually, when that's all said and done, your box will look, your box and whisker plot will look something like this, where you'll have the lower quartile again, which is represented by the values between the lowest extreme and the median, and likewise from the median to the highest extreme. I encourage y'all to take some time to solve that out on your own and try to figure it out. Good questions. Got time for one more.
Okay, what would happen if the number of data points ended in an even number?
Good question. As we saw in the last question, the number of data points was odd, and that allowed us to find an median just like that. But if there is an even number set, there's no true middle number. In that case, you'll be looking for the median by determining the average of the two numbers. So, for example, if you had numbers 10, you wanted to find the median, you would go in between. You take the even number of points between the two medians. In this case, our middle number is somewhere in between 5 and 6. So 1 through 4 and 7 through 10 are not our median. That leaves 5 and 6. So to find the median, you would take 5 and then add 6 to it. And then once you have 11, you'll find that 5 plus 6 is equal to 11, and then divide that by 2 to get your median, which is 5.5. Thank you for asking. With that all being said, I would like to turn this over to you, Johnny.
Oh, awesome. Okay. Well, for my presentation, honestly, I'm just going to be showing y'all more ways to present data. And starting out with mine, we're going to go over some more graphs, okay? Because some of the better ways to present data that I've come to find out is with graphs. So just different things that you'll need to know or that you will come to know during my lesson here is mean, median, x and y axis, histogram, frequency table, bell-shaped curve, skewed left and or right, and then outlier. Now, as we go along, you'll figure out what each of these mean. And then if you don't know what they mean, feel free to ask me or email me, and I will let you know exactly, or you can always Google it and find out that way. But hopefully I will do a good enough job of presenting this to you, and you will figure out what each of these mean. So for my first one, this is just generally the types of graphs that I'm going to go over. I have a histogram. Bell-shaped curve is the one that I'm going to go over. But I also have to show you a bar graph because a histogram and a bar graph are very similar. So I'm going to need to show you those two, and so we'll figure out the differences between them because I don't want you getting mixed up at all. There's no point in me showing you all this if you're just going to be mixed up by the end and the time that I'm done.
And that was actually what I was going to ask you is how would you compare and contrast a bar graph and a histogram?
Oh, thank you. That's actually really good. So, bar graph and histogram. A bar graph, this is used to show single events. Different events like different grade levels, the different bars do not touch, okay? So like if we came back here, this is just showing age ranges right here. So, but they do touch, okay? And these are just different age single events. And right here, bar graph, you have the US, India, UK, New Zealand for NZ, and Japan. And this is just showing the, let's say, like amount of monies they have in the categories or just different countries. Now, over here on the histogram, as you can see, there's no gaps at all. There's gaps right here, no gaps. And right here, we're kind of comparing the number ranges, okay? So we have 100 right here, and then we have, it's 100 all the way to 150. And then we have 150 to 200, and it continues to go on. Now, these are touching, and then there's the amount between 100 and 150 is about 20 or so, a little bit above. And then from 150 to 200, it's a little bit less than 120. But then we're going to hop back over here, and then this is bar graphs, back to bar graphs, the number of a certain category. And as you saw in the slide that I just showed you, like the US, showing you how much money essentially like the US has, okay? And the bar graphs, again, they do not touch. But a histogram, this is a range of data. It's more used, not always, but more used for a range of data. Now, these will be presented with numbers, and there are no spaces, bars, not touch. But at the same time, both of these are used to represent data and to compare them. So you can be the ones to represent and compare data, but they're generally used for different kinds of data. As in,
Okay.
the histogram is for range, and the bar graph is for single events.
Okay. I'm still a little bit lost. Could you kind of go in more depth about the histograms, features, and parts?
Oh, cool. Thank you. Awesome. So the histograms right here, the histogram just features and parts of it. And I think this one would be better
Mm-hmm.
to show you for it, as in all
Mm-hmm.
graphs have these essential features, okay?
Mm-hmm.
So right here, where we have 1 through 10, that is the y-axis, okay? The y-axis is just telling us how much of something that we have. And now
Mm-hmm.
down here we have the x-axis. Sorry, there we go. The x-axis right here. The x-axis is telling us what we are talking about. Now, don't
Okay.
get that mixed up with the title up here, what kinds of pets do you own? Down here, we have
Mm-hmm.
rabbit, dog, cat, goldfish, and hamster. Those are the kind of pets that we're talking about. Okay, that's
Okay.
x-axis.
Okay.
And
So
then, yes,
what I'm getting is that the histogram tries to focus on subjects, whereas your bar graph seems to be focusing more on just solely the numbers. Is that
well, the
correct?
thing is, you can go either way with it, but generally more, these are just pictures that I found online, but generally more, you'll kind of see a histogram with these kind of numbers like 2 to 29. Because
Mm-hmm.
look, you can make a bar graph with this one also. Okay. Like
Okay.
back over here, these are generally, just generally, not always, but generally, histograms are used for a range of data. So, like, generally, you would see a histogram like this, but the bars wouldn't touch.
Mm-hmm.
And then over here, the bar graph is normally used for a single event. So, back over here, these are like kind of single events, like a rabbit, dog, or whatnot, like that. Or like over here, you have the US, India, different things like that. And then you
Mm-hmm.
have this histogram showing the range of data. Now, can they kind of be mixed with different things? Yes, but these are what they generally are used for.
Okay. All right. Thank you so much. Now, can you go forward the slide to where you had the three types of graphs? There was
Right here.
one. There's one on there about. There it is. The bell-shaped curve. Could
Hmm.
you explain what that is?
The bell-shaped curve, okay, so the bell-shaped curve, it's kind of like the histogram. As you can see, the histogram, you look at the curve from the bell-shaped curve right here. The
Uh
histogram,
huh.
it has the pretty much the same curve. And as you can see in the middle is the high peak. And the high peak is normally where you will find your mean or your middle number. Mean is
Mm-hmm.
means middle number. And as you can hear what I'm talking about, we're hitting these different vocabularies, okay? So just
Uh
kind of
huh.
don't forget about these. We're still hitting those, okay? So
Okay.
your mean, which is your average number of like your middle number,
Mm-hmm.
it'll be in the middle. And on a bell-shaped curve, it's showing you essentially normally where your mean is. And this is just a regular,
Oh.
this is a regular bell-shaped curve, normal distribution
Okay.
between them. So your mean will be right down the middle on these, okay? So our mean on this one is essentially about 75 or so because you have 70 and 80, and in between there, the middle number is 75. And that's the high point right there. Boom. That's the high point right there.
Oh.
Yeah. And
Okay.
then,
Thank you so much.
yeah, and so far
Now,
we've hit
what?
on mean, X, Y axis. We've showed you a histogram, and I've showed you a
Mm-hmm.
little bit of the bell-shaped curve. Haven't gone into skewed left or right. And I haven't really shown you the median yet. I mean, not the
Mm-hmm.
median, the mean, because the median is the one that's the middle number. I misconstrued some of that there, but the median is going to be the middle number where the middle of this graph is.
Okay. All right. Now, you've been throwing out these terms. Let me ask, what elements would, such as mean, median, and mode, would you change if you added an outlier number to the data?
Oh, great. So, um, right here, and I wanted
Mm-hmm.
to introduce you to a frequency table, which this is what a
Okay.
frequency table looks like. And it's kind of like the stem and leaf plot that Mr.
Mm-hmm.
Hamashek showed to us earlier. And mine are over here, and it's 111 through 15. And I can essentially make this smaller, but not smaller, but like having the tens placed on the left side over here on the left
Mm-hmm.
side, and then having the numbers of the occurrences on the right side, which is what he showed us. But mine is 11 through 15, which is in increments of 5 instead of 10, which it's just
Mm-hmm.
fine. You can do it in 10, you can do it in 5, but you have to show how many times a number in that range shows up. So you have 11 through 15, frequency is twice. And as you can see, it goes all the way down, okay? And this
Okay.
is to show the data from a histogram. And it will show it for bar graph as well. To the left is the numbers, and then to the right is just how many times it shows. Now, over here,
Mhm.
you want to, if you added an outlier, like you asked, over here, I had the numbers and I went ahead and did all this because it's a lot of numbers, okay? There's 40 numbers on here,
Mhm.
and I don't want y'all to have to kind of do this while I'm trying to teach this. Now, if you want to go back and look and see if I did this correct, please do, okay? But I went ahead and did this with just the regular 40 numbers. So we'll have the set data that we're dealing with, which is right over here. And I put out the mean of this data right here, all these numbers together. The mean is pre-estimated, which I did first, is 75.7. Now, the median, which like he showed us earlier, you can count. Me personally, what I do is I would essentially put a 1 on 76 and a 1 on 57. And then I would just go down the line until I reach a number that's the same. And what happened is once you put these numbers in order, and you can go down in order, everything like you want, count the numbers. I go from left to right and then right to left and then meet up in the middle. That's what I personally do. And because I like visuals. And if you do that, you'll meet up at 78. 78 will be the number that would be your median. And on here, you don't see a 78 at all. I believe I have a 77 and a 79. And what happened is that we had it in the middle of 77 and 79. So 78 was my median. And then the mode of the data, which is the number that showed up the most, is 75. Now I went ahead and also added 25 to this set of data. You don't see it up here because it's an outlier. I added it after. So if I were to add 25, it would be 41 numbers. Now, the mean of this is 74.46. The median would then change to 76. It would go down because I added a lesser number. And when you're
Mhm.
counting, you want to find the mean, you're only using these numbers. You're counting these numbers. So then when I counted all these numbers, the mean that came to the middle, which essentially would be number 20, just counting like left to right or right to left, it would be 20 with the number 41. And that
Mhm.
landed me on 76. So my median for the set of data is 76 and the mode is still 75.
Okay. All right. Thank you. How is the histogram related to the bell-shaped curve? How are they similar?
Great question. So right here, I have my histogram created from that frequency table. And like I showed you earlier, you see this bell-shaped curve. There's kind of a curve that shows you like right in the middle. Boom. There's the median. That'd
Mhm.
be like the middle of the
The
data.
line of
Yes.
deviation? Is that what
Uh-huh.
they?
Yes, that's the
Okay.
line of deviation. Now, we're not going to get too particular with this, just because we're going over just different kinds of graphs. Now, if it's specifically
Mhm.
for a bell-shaped curve, I could tell you all about this. But the middle of this, how it kind of starts low on the left side and then goes up to its peak, the median, the
Mhm.
middle number, and then it goes down here, boom. And it's all, this is your mean, gives you your mean right here, and that would be the middle of the graph. Now, if you come over here, we'll go all the way back to the beginning because it gives us a great one with the different types of
Mhm.
animals. So you see right here how it has a high point. That's the middle of the graph. And also
Okay.
over here,
Mhm.
this one, because generally your histograms, like I told you earlier, will be using
Mhm.
ranges of numbers.
Mhm.
This one's great too. Now it doesn't go as low over here, but the curve is still essentially the same because as you can see right here, it has a high point, and this is about in the middle. So we're going to call this the high point right here, okay? This is the
Okay.
high point. And then it kind of curves down, as you can see,
Mhm.
and it looks like this one too, just with not as much data.
Oh, it does, doesn't it?
Uh-huh. Yes. So then it just
All right.
has the little bell-shaped curve. If you were to draw it in there, boom, you would see the
Mhm.
little bell-shaped curve. And that's how they're related because it's representing data. And essentially in the middle is where your mean will be.
Okay. All righty. I got. Are you done answering?
Um, there's one more thing that I wanted to hit on.
Mhm.
I wanted to let y'all know about skewed lines.
The skewed line. Are you
Yeah.
gonna
hmm
explain how that works?
Yes, skewed lines. Now,
Okay.
on this set of data, which I created from my frequency table earlier, skewed lines,
Mhm.
we have a thing called skewed left or skewed right. There are two different types, skewed left, skewed right. The left and right refer to the directions of the downward slope that is not at as high as the others. So let's say I was having a graph like this. This is my high point, okay? Now, it's going to go downward to the right. So since it's going downward to the right more than it is left, because my graph stops right here, okay? It's going to go further
Okay.
right than it is left. So this one will be called skewed right. This graph stops.
Oh, okay.
Now, if I were to flip it to where everything is over here, and let's say my 87 to 97 was all the way up here at 14, and then my 57 to 67 was all the way down here at 2, it would be left because it's going left, downward left.
Okay.
So that's left. And honestly,
Okay.
it just shifts the data. So
Okay.
let's see. I'm going to go all the way back to the beginning for you. And right here. So let's say we had the high point over here, okay? High point's over here. And it's going to go skew down to the right. Boom, over here.
Skew down to the right.
Yes. Essentially, our high number or our average, the mean, it's going to fall over in here more. Oh, sorry. It'll fall over here more, okay? A high point will no longer be really where the mean is. Okay? But I mean, you'll still have your mode because your mode is the most occurring one. Still be over here, high and everything like that. Just the mean and the middle number will shift a little bit. Now, normal distribution, normal bell-shaped curve, it'll all be pretty much centered around here. But with skewed left or skewed right, your mean or median will move left or it will move right. So with skewed right, everything's moving to the right. With skewed left, everything's moving to the left.
To the left?
Yes.
All right. I'm following along now. All right.
And yes, yeah, definitely. But I mean, that's really all that I have for you guys. I mean, I hope. Oh, here you go. See, as you can see, this one is skewed left. You can see a visual. And your mean falls down here. Your median's more towards the high, but it's still to the left. Now, your mode will not change at all. And the reason they become skewed is because of the outlier. And as you can see before, as I did over here for you, I added the outlier. And the outlier, what it changed was the mean and the median. As you can see on the bell-shaped curves over there that I showed you, the skewed left, skewed right, it changed the median and the mean, but not the mode. The mode will always stay the same. Okay, so that's something important to remember. And right here, as you can see, I showed you skewed right, everything is going to the right. Skewed left, everything is going to the left. Now, was there anything else, Mr. Hamashek, that you wanted to know?
I think that about covers it.
All right. Well, that's all that me, Mr. Scott, and Mr. Hamashek had for you guys. I hope that you were able to learn something tonight, and I hope that you had fun. If you do have any questions, honestly, we're always open for emails or anything like that. Please shoot us an email, or you can just talk to us sometime that you find us free. And for extra work, if you want to go do it, which I would really recommend you do this, okay? And there's a link right here. I gave you a link so that way you can go and work problems 1 and 2 on page 67 and 69. These are over frequency tables. Then you can go down to page 97. You can work problem number 2. And then go down to page 99, work problems 3 through 6. Both pages are over histograms. So these aren't anything that's like super tough, but it will expand on your learning, and hopefully you will get the correct answers and you will kind of be able to wrap your head around what we've talked about. And if you want, you can also go do more problems on there, but these are the problems that I would highly recommend you do. So thank y'all for listening, and I hope that y'all really enjoyed it.
Have a good week, y'all.
Yeah. Thank you so much.